Today we're going to talk about solving two-step equations. Remember, when solving equations, our goal is to get a variable by itself or to solve for a variable. Another way to say this would be to isolate the variable. That just means to get it by itself or to solve for the variable. To do this, we have to use inverse operations. If you remember, the inverse operations are operations that undo or are opposites of one another. So the opposite of addition would be subtraction, and this relationship works both ways. So the opposite of addition is subtraction, and the opposite of subtraction is addition. And then multiplication is the inverse of division, and again, the inverse of division would be multiplication. Some examples of inverse operations would be, we're going to look at these using one-step equations for right now, and we're also going to talk about some properties. So the first equation that we're going to look at is x minus 3 equals 2. In order to get x by itself, or to isolate x, we need to do the opposite of subtracting 3. The inverse of subtracting 3 would be to add 3. And when we're solving an equation, we want both sides to remain equal or to remain the same. So whatever we do to one side of the equation, we have to do to the other side as well. So if I add 3 to the left of the equal sign, I have to also add 3 to the right of the equal sign to keep an equal balance, or to keep the equation equal. When I add 3 to both sides of an equation, this is actually going to be called the addition property of equality. Adding the same number to each side of an equation produces an equivalent equation. So that's what I was saying, whatever you do to one side, you have to do to the other to keep the two sides equal. When we add 3 to both sides, negative 3 plus 3 would cancel out, and we're going to be left with x equals 2 plus 3, which is 5. Next, we're going to look at the one-step equation, x plus 7 equals 10. In this case, we have to do the opposite, or the inverse, of adding 7. The opposite of adding 7 is to subtract 7, and just like in the previous example, whatever we do to one side, we have to do to the other. When we subtract the same number from both sides, this is going to be called the subtraction property of equality. Just like the addition of property of equality, the subtraction property of equality says subtracting the same number from each side of an equation produces an equivalent equation, or the two sides remain equal. In this case, when we subtract 7 from both sides, we're going to be left with x equals 3. In the next example, we're given x divided by 2 equals 6. The opposite or inverse of dividing by 2 is going to be multiplying both sides of the equation by 2. This is going to be called the multiplication property of equality. Multiplying each side of an equation by the same non-zero number produces an equivalent equation. When we multiply both sides of this equation by 2, we're going to be left with x equals 12. And the last property of equality is going to be 4x equals 24. In this case, we're multiplying 4 times x. The opposite of multiplying by 4 is to divide by 4. Whatever you do to one side of the equation, you have to do to the other. In this case, dividing by 4. This is called the division property of equality. Dividing each side of an equation by the same non-zero number produces an equivalent equation. In this case, when I divide both sides by 4, I'm going to be left with x equals 6. Those were basic one-step equations to talk about the properties of equality. Now we're going to talk about solving two-step equations. To solve a two-step equation, you have to perform two operations. To do this, we are going to reverse the order of operations. Generally speaking, that means that we're going to undo addition or subtraction first, and then we're going to undo multiplication and division. And I put in there usually because there is one type of equation where you're going to actually get rid of the division first, and then you're going to get rid of the multiplication or the addition or subtraction. And there's an example of that in the next couple of examples. So the first example is a really basic two-step equation. It says, what is the solution of 2x plus 11 equals 51? So start with the equation. We need to undo the order of operations, so we're going to undo the addition first. To get rid of adding 11 on the same side as your variable x, you need to subtract 11 from both sides. When you subtract 11 from both sides, 11 minus 11 is going to cancel out and leave you with 2x equals 40. Now you need to get rid of multiplying by 2 by dividing by 2 on both sides. When you divide by 2 on both sides, you're going to be left with x equals 20, and you've solved your two-step equation. Very quickly, you can use mental math. In this case, you could plug it back into the original equation. You can plug in or substitute in 20 for x, and you can quickly in your head tell that that will create an equivalent equation. 2 times 20 would give you 40, and then plus 11 is 51. So that is what we wanted the solution to be. The next example says a train is 100 miles away from a station. It is approaching the station at 40 miles per hour. How long will it take the train to arrive? We're going to set up a basic one-step equation to solve this. It has 100 miles to travel, and it's traveling 40 miles per hour. So I'm going to multiply 40 times h, which is going to represent the number of hours, which is how long it will take the train to arrive, and set it equal to 100 because that's how far the train has to travel. To solve this equation, we would divide both sides by 40. 100 divided by 40 is 2.5. So it would take 2.5 hours for the train to arrive to the station. This example is the one that I was talking about, that you are not going to actually get rid of addition or subtraction first. So it says, what is the solution of x plus 5, the whole thing, the whole sum of x plus 5 divided by 6, which equals 15. Now, having this written like this, you could also imagine that there were parentheses around x plus 5. That kind of helps you see that when we reverse the order of operations, parentheses come first in the order of operations, so parentheses would come last when we're solving an equation because we reverse the order. So in this case, to get x by itself, we actually need to multiply both sides by 6 first. When you multiply both sides by 6, on the left-hand side, your 6 and you're multiplying 6 and the 6 that you're dividing by would cancel each other out, and you would be left with x plus 5 equals 90. Now you need to undo the addition, so you would subtract 5 from both sides, and when you do that, you would get x equals 85. The last example says, what is the solution of of 10 plus 2x equals 20? And this problem asks us to justify each step. So we're going to start with the equation that they give us. We actually need to get rid of the positive 10 that's in the front of the equation first by subtracting 10 from both sides. The justification for doing that would be the subtraction property of equality. We can subtract 10 from both sides of the equation, and the equation will remain equivalent. When you subtract 10 from both sides, you're going to be left with 2x equals 10. Now you need to divide both sides by 2. The justification there would be the division property of equality, which just says I can divide both sides of the equation by the same number, and it will remain equivalent. And when you divide both sides by 2, you are left with x equals 5.